Okay, for this recording, sizobese focus on question 5. It's actually based on a application of a differentiation. There's also gonna be a discussion on our cubic functions. I'm quite surprised Guti, there's also a discussion on a factor theorem, right? I think on one of the questions, if not question 1, it should be question 2. In this very same question paper, I'll leave my links for all the questions that I've answered for this question paper in the description box. Just while watching this video, just scroll down and check the description box. I'll leave my links for each of the questions. Question 1, inside my brackets, you'll see a link inside. Just click on it and then it will take you to one of the questions. Also, be interested, you. So yeah, factor theorem, cubic function, as well as the application on a differentiation. That's going to be the discussion in this lesson here today. This is question 5. Thanks for tuning in, guys. Now, level 5.1, they are showing us a show jumper that attempts to break a world record. His motion is expressed in terms of distance as in meters and time in seconds. The equation of motion is given as this. Okay, so the S represents any distance. The T represents what? Time. So the distance is a what is it? A quadratic equation, right? It's a parabola, right? So the distance is a function of what? Of time. The distance covered is a function of time. So say a show jumper tonight. Probably starting la, jumping all the way up. So the target la, or the aim or the goal of the exercise is just to jump as high as possible and then dropping all the way down to Bani to point A. Okay, so Lapago 5.1.1, the first question, they want us to determine the height of the show jumper at T3. At T is equal to 3 seconds. Now, this might be T1. Now your height here, this is T equal to 1 second. This might be T2, and then this might be T3. The height here, right? So we want to find out with the jump how high when T is equal to 3 seconds. So in this way, calculate. So it's a 1-mark question. This is the equation used to calculate what? The height jumped plus 1. Okay, so T is equal to body is equal to 1. Alright, so let's calculate this. No, T is equal to 3. What am I saying? T is equal to 3. So the equation, where does T you substitute to bani with 3? Minus 3 squared plus 3 3 plus 1. So let's calculate as tola what. Let me grab a calculator. Let me just grab a calculator. It's minus 3 squared plus 3 plus 1. I'm getting 1 meters. So this is the answer. Okay, this is the answer. Then go 5.1.2a, determine the maximum height of the show jumper. The maximum height of the show jumper. So this is what I'm gonna do. 5.1.2a, the maximum height. So the maximum height, Nyla, the maximum height, it's actually what? The turning point of this parabola. It's the turning point of this parabola. But I think this question, the key word is maximum, right? It's maximum. So maximum or even minimum for that matter, I know I need to be finding any derivative, right? A derivative, and I know that the derivative at the maximum or a minimum, the gradient of a tangent at a point on a curve is equal to 0. So, meaning that in order to get a maximum yakho, or even a minimum, you would have to find the first derivative of the given equation and equate it to 0. Bese we are solve again afterwards. So in this way, we're gonna take the given equation minus t squared plus 3t plus 1, and then we find the first derivative, s prime t minus 2t plus 3. All right, plus 3. So this is the first derivative. 2 times minus 1, it's minus 2. Below 2, you subtract 1, it's only 1. 1 times 3, that's 3. And then you take away 1 from that 1, usala no 0. So any number raised to exponent 0 is what? Is 1. So that is why sisala no 3, right? So that's the first derivative. And then equator to bani to 0. And then you solve for t. You bring the t over the side. T is equal to 3 seconds. 3 is equal to 3 seconds. 2. Oh, I'm surprised with why are we actually getting a 2? I mean a 3. While 3 basiphe and so tena substitute by the 3, so it's actually not the maximum. But anyway, we now transpose 2 minus 2t. Naga figure about positive 2t. 3 divided by 2 divided by 2. Then t becomes 1,5. 3 over 2, that's 1,5 seconds. Determine the maximum height of the short jump. Alright, logo besu calculator. We're actually calculating the time where the maximum height is reached. Ne? So after 1.5 seconds, we are reaching a maximum height. The question is, what is the maximum height? So we have to go back to the equation and substitute ubani 1.5 minus 1.5 squared plus 3, 1.5 plus 1. So this is what is happening here. Ne? So after finding the time at which the maximum height is reached, this will calculate the maximum height by substituting the time back to the original equation. Minus open bracket 1.5 squared plus 3, 1.5 open bracket, yes, plus 1 equal to, I'm getting an answer of 3.25 meters. So this is the maximum height, right? So the maximum height is reachable. T is equal to 1.5 seconds. So the maximum height is reached at 1.5 seconds. What is the maximum height? We calculate here now, 3.25 meters. Now go B. They are saying that the current world record naila. So before we show jump away to making the jump, the standing world record show it was 2.47. 2.47. Now check what you reach a maximum height of how much? 3.25 meters. So we set a new record. Now group B, they are asking us by how many centimeters did he exceed the world record, or was short off to reach the world record. Okay, it seems like, in fact, it doesn't seem like, actually he exceeded the world record. So we set a new record. This was the current world record. Yeah, now we jump a maximum height of this much. Group B, they want us to calculate the world record by how much. Ne? By how much? So lapha group B is gonna be equal to, so tata the new world record set by E will jump by you to 3.25 meters. See minus by the standing world record, that's 2.47. 3.25 minus 2.47. Answer 0.78 meters. 0.78 meters. Si multiply by 100. Sithola ubani u 78 centimeters. Now, but is it by how many centimeters? Yes, sidila ngama meters, but nangithola the difference between the new world record and the current standing world record. So it's 0.75. So we're subtracting so that it's udlule the world record by how much? Udlule by 0.78 meters, but the question is in centimeters. That is why you multiply by 100. Multiply by 100. Why? To change our meters to our centimeters. That's what you do. You multiply by 100. Okay. 5.2. I think I won't be needing the sketch anymore as is so that it generated some space so that it's always okubhala. Now 5.2.1, given that f prime of x is equal to 6x squared plus 6x plus 12, determine the value of p in f of x. Now 5.2 is the third degree polynomial, Nyla. This is the third degree polynomial. It's given now, but p is unknown. All right. Now, but now tata le, when you take the f of x with differentiator, you should get something like this. Né? But let's take the original equation. F of x with 2x cubed plus a 3x squared minus px minus 20. Okay, then city f prime of x is equal to 6x squared plus 6x, then lana siba no minus p, then lana kuba ubani u0. However, lapho 5.2.1 they gave us the derivative of f. It turns out kuti yona ke is equal to 6x squared plus 6x plus 12. Do you see what's happening? So, we must start the original equation and differentiating it. I'm getting this, but p is unknown. So, on the given equation in the question, kuno 12. Where's this 12 coming from? So, Lago 5.2.1, they are saying if p bega corner, this is what you have, this is what you would have gotten after differentiating. Yabon? Gahle u12 is linked to a solution here to appeal, right? So first derivative from the original equation. The first two terms are similar to the given equation, right? But now tina sino p after differentiating that equation, and then the given equation has ubani u12. So this means that the minus p should actually be equal to ubani u12. But now remember, I took u minus p, I took the p with the sign corner, which is negative. I took u12 in the sign corner, which is positive. Divide by u minus 1 minus 1, then p is equal to minus 12. So this is my value for p. All right, this is my value for p. It's a bit tricky nyana, but just it requires ngathi beyifuna ukuthi ucabange a little bit, ne? So 5.2.2, x plus 2 is a factor of f of x. Hence determine other factors of f of x. All right. This is what I was saying with it. This question is somehow related to effector theorem, which is actually, now this is f of x, iphelele. This is the full equation. 2x cubed plus 3x squared plus 12x minus minus 20. Okay. Okay, so Lana made a mistake. It should be minus 12. That should be minus 12. Alright, x plus 2 is a factor again, right? So 7 is the synthetic method. X plus 2 equal to 0, x is equal to minus 2 is a factor, is our first factor. So 7 is the synthetic method where Sibano minus 2, it's this minus 2. And then we have this expression, which is 2 plus 3 minus 12 minus 20. We take this 2, we drop it. And then kuba 2. We take this minus 2 and times this 4. I mean, take this minus 2 and times by this 2. Sitolo minus 4. Add, we get to minus 1. Repeat the process. Uthathu minus 1 times ano minus 2 times ano minus 1 is total positive 2. Minus 12 plus 2, I'm getting a minus 10. Minus 2 times minus 10, the answer is positive 20. Tata lo minus 20 nalo positive 20 ba add utolu 0 la. Alright, now this answer now becomes what? A trinomial, right? It becomes a trinomial, which is 2x squared minus x minus 10, right? Minus 10, and then putting back factors weight, that's x plus plus 2, and then 2x squared minus x minus 10 is this. It's coming from this, equal to 0, right? Equal to 0. Now we have to find factors amanye. We have to find the rest of the factors, which are so lana we are not solving for x anyway, so whether you have the 0 or not, that's fine. So this is the first factor, which was the given one. Now we have to factorize this trinomial so that it's totally amanyama factors. Lo 0 uzomfaka if you wanna find x-intercepts. If this was a cubic, uzofaka 0 and solve for x. But lana it's not a cubic. We are given a function, we just have to find factors for that function. Ne? So anga confuse lo 0 ngumfake lapha, anga confuse. So x plus 2 is the given factor. We have to get factors for this. Now we're gonna use the factorization. Ne? We're gonna use the factorization. But if you know how to manipulate the quadratic equation and getting factors, I don't see a problem over that. 2x minus 5 and x plus 2 are the factors, right? So just do it in a quadratic equation. I think that's quicker. Né? If ever you feel like I'm stuck, man, I don't know how to get how to factorize a trinomial, just use a quadratic equation. So this is the given factor. The last two factors are the factors we were looking for. So 5.2.2 pelelala. Alright, we have our factors guy f of x. Okay, next up 5.3. 5.3. Lana we are talking about a cubic here, man. Another cubic. So we are given this. Determine the gradient of g at x equal to minus 2 and x equal to 1 by applying a differentiation. Alright. So 5.3.1 CTF, no, it's G. We are given G of x to be 2x cubed minus 7x squared minus 14x plus 40. Now, determine the gradient of G. Now. Maybe now 70 read just to emphasize on this point. Gradient of G. In calculus, once you speak about the gradient, just know that it's actually a derivative, right? You're gonna have to find a derivative and equate these values. Then uzotholama then you'll get your gradients at these points. Asiyenze while isashisa le ndaba. Alright, first derivative is 6x squared minus 14x minus 14. This is the derivative, first derivative. Now, gradient at x equal to minus 2. It's g prime of, so like no x corner, ngiyofaka u minus 2. 6 minus 2 squared minus 14 minus 2 minus 14. So punching this into the calculator, 6 minus 2 squared minus 14 minus 2 minus 14. I'm getting with 38. Now the gradient is 38 at x equal to minus 2. For this function, number 2, gradient number 2, at which point at x equal to 1. G prime of 1, 6, 1 squared minus 14, 1 minus 14. So sifaka 1 la. We come back, sifaka 1. Ngithola ukuthi answer ubani? Minus 22. Minus 22. Now but is we explain at the answer about 5.3.2. Explain what happened with the curve between x equal to minus 2 and x equal to 1, and give a reason for the conclusion. Alright. Okay. Now, gradient yet, we can see that it was once positive from x equal to minus 1. And then going to x equal to 2. Actually, Cartesian plane yet, it's like this. It's like this. Gono minus 3, gono minus 2, gono minus 1, go 0, go 1, 2, then 3. Okay? And 3. So the gradient was what? Was positive. So the cubic was doing something like this. So then once it reaches x equal to 1, this point, now minus 2, the curve is going up. If the gradient is positive, it means that the curve is going all the way up. If a negative gradient, the curve is going downwards or sloping downwards. So at this point, x equal to 1, the tangent, the gradient of a point at a curve is negative, meaning that now attach a tangent to that point, it's gonna slope downwards like this. If the gradient is positive, attach a tangent to it, it's sloping upward like this. So that is why the gradient is positive, because the tangent is sloping upwards. Okay, so this is just a typical part of this cubic, right? Just a portion of it. Now it changed from a positive gradient being 38, positive 38, to a negative gradient being a minus 22. All right, so from going up to going down like this. So 5.3.2. So the first part of the reasoning would be gradient increased from positive to negative. Of course, when fully the gradient increased from positive to negative, and give a reason for the conclusion. Maybe it's not there. Okay, that's not therefore, but gradient increase from positive to negative. This means between these 2 points there is a maximum turning point. A maximum turning point. I think this is good enough. This is good enough. So gradient was sloping upwards. Sadlula past this this turning point, and then it started sloping downwards. So there was a maximum point between these 2 points. Determine the point of inflection. Determine the point of inflection. So now at the point of inflection, you need both the x and the y coordinate for this point. So determine the point of inflection. So the point of inflection is ithola by finding the second derivative. Point of inflection is calculated through the second derivative. Through the second derivative of the function. So g double prime. Okay, I erased the first derivative, but as you check, let's see if I can't find it. Okay, there it is, there it is, there it is. Okay, should I erase? Okay, yeah, why not? That's Rabela. I'm gonna change this. As I keep this equation for demonstration. So we are doing the last question, 5.3.3. I'm going back to this part of his screen because see, I doing the first derivative. Now remember, we want the second derivative to find the point of inflection. So I'm taking the first derivative of the first derivative. This is the original function. This is first derivative. Second derivative is taking this function and differentiating it again. So it's going to be g derivative of a derivative, or the second derivative, is equal to, so tata this derivative we differentiate 40. So 2 times 6, that's 12x. 1 times 14, that's minus 14x. No x. It's just 14. Alright, then we equate it to 0, you solve for x. Transpose of 14, you got positive 14 equal to 12x divided by 12 divided by 12. 14 over 12, not 11, but 12 is equal to 1.167, 1.167. You round off to 3 decimal places. This is the x value. This is the x value. Then you take this x, we substitute it back into the original equation so that you can get in the y coordinate. Nope. Okay. 1.167 close bracket, that's cubed, minus 7x close bracket, minus 14, 167 plus 40. Answer is substitute I think double check. 1.167 minus 7x squared. Okay, look square along. Then 14x plus 40. Okay, so the y is gonna be equal to 17,307 in 3 decimal places. Yes, in 3 decimal places. That's gonna be our answer. Okay, that's gonna be our answer. All right, this is y, this is x. So the full coordinate looks something like this: 1,167, 17,307. This is our answer. Okay, so this concludes our discussion for question 5. Check out the description box for more content in creative for the November 2023 question paper. So for now, signing out. Phone, comment in the comment section. Let's have a conversation. Sharp.